Hello student, welcome to my channel. Today we are going to study about new topic related to operating system. So I hope that you have watched my previous video related to operating system. So let's get started. Today we are going to study about structure of operating system. What do you understand by the structure of operating system? As we know that operating system is nothing but the system software which act as an interface between user of a computer and computer hardware. So it is a basic software which needs to be installed in your system. So what do you understand by the word structure of operating system? As operating system is a large software, it is going to perform many of the tasks. So you can imagine it as various components. So how the components are being connected, how the common component of operating system are being connected, that is nothing but the structure of operating system. How the components are connected, how it is interconnecting, how it is being integrated, how all the system work as a one system. So that is nothing but the structure of operating system. So the operating system structure illustrates the organization of module inside it. So as we can see that operating system is consisting of various modules. How the modules are being connected, how it work, that is nothing but the structure of operating system. So you can say that the approach of interconnecting and integrating multiple operating system component into kernel can be described as the structure of operating system, or you can say operating system structure. So which are the various structure of operating system? The first is the simple structure. What is simple structure? In simple structure, such structure is not well defined. It is used for small, simple and limited system. The interface and level of functionality is not well separated. MS-DOS is the example of such operating system. So you can see that this is a main device driver. For example, this is for the MS-DOS. These are the application program. These are the other programs. Now you can see this is the way in which it has been connected, or it is going to uh, access this core component. But over here the resident program can also access this directly, and the application program can also direct it or access it directly. So you can say that it is not well defined, it is not well separated. So what are the advantage of system or the simple structure? The main advantage is it deliver better application performance because of few interface. The interface are very few, so it is going to deliver the better performance. And as you can see, the kernel can be easily developed for such kind of operating system. And what is a major disadvantage? The major disadvantage is if any of this application program or any of this resident system program fails, your entire system can crash, your entire system can come down. Okay, as every layer can access this main component, so you can say that it do not enforce data hiding. It do not enforce data hiding. Any of the layer can access data from any of the layer, and it can lead to data modification. The program over here can access the data of your over here, and it can modify the data, so your operating system can crash. So in simple structure, it is not well defined, it is for simple and limited system. Any layer program can access the core component, they can modify it. So it is not a suitable solution or the best solution for the structure. You cannot opt for this if you are going to make a operating system, or you are going to develop an operating system. Next structure is the layered structure. From the name itself, you can understand what is a layered structure. An operating system can be broken into pieces and retain much more control on system. Now, your operating system is broken down into the layers, and the bottom layer is the hardware and the topmost layer is the user interface. So you can see this is the bottom layer and this is the topmost layer. So every functionality, depending upon the functionality, it has been categorized in the layered. Depending upon the functionality of the modules of the component, it has been categorized in the layers. Unix is an example of such structure. Now, what is the advantage of this layered structure? Now, in this layer structure, it is useful when one of the layer needs to be changed. If any of the program at this layer needs to be changed, it can change easily without affecting the other layers. You can find out the errors, you can debug the layers without affecting all the other layers. So this is the main advantage of layered structure. And your data moves from one layer to another, interpreting it via the layers. And the major disadvantage of this layered approach or the layer structure is the performance is degraded. Now, why the performance is degraded? Whatever request is there, it is first interpreted via this layer, then this layer, and this layer. So at each of the layer, your performance get degraded. Why it get degraded? Because whatever is your requirement, the requirement moves from one layer, it is interpreted to another layer, then it is interpreted to another layer until it reaches the hardware layer. So it requires a very careful planning. It requires a very careful planning for designing the layer, as higher layer uses the functionality of only the lower layers. This layer uses the functionality of this layer uses the functionality of this layer. So while designing such operating system which is going to use the layer structure, okay, it is you have to be very much careful. Okay, understood? What do you understand by the layered structure? In the layered structure, the operating system organizes as the hierarchy of layers. It is going to organize as the hierarchy of the layers, and the bottom layers is the hardware and the topmost layer is the user interface. Next, we'll study about monolithic system and the microkernel system. What happened in the monolithic structure? In the monolithic structure, the entire operating system works in the kernel space. What do you understand by kernel? Kernel is the core component of operating system, or you can say it as a heart of operating system. And in the microkernel, only the main thing or the main component work in the kernel space. So the microkernel is a kernel type that provide low-level address space management, thread management, inter-process communication to implement an operating system. So we'll study in depth. First is the monolithic kernel system. Now in this monolithic kernel system, the kernel acts as a manager, and it is going to manage it is going to manage files, it is going to manage memory, it is going to manage device and the other operational processes of operating system. You can say that kernel is the heart of the operating system. So you can see over here, entire thing works in the kernel space. Entire thing work in the kernel space. So any of the operating system which is going to use the monolithic structure is called as the monolithic kernel. What is the advantage of this monolithic kernel? It is simple to design because simple to design the operating system because every task is being operated in the kernel space, and layering is not needed as in the layered structure, and the all the services like memory management, file management, process management are being implemented in the same address space. So you can say that monolithic kernel is relatively fast. It is relatively fast as compared to the normal system. What is the disadvantage of this monolithic structure? If any service in the monolithic kernel fails, then entire system can fail. So you can see that if any of this functionality, like if there is an error in this file management, so entire kernel can fail. So you can say that it is not flexible, and uh, if you want to add anything, so it is not flexible. I hope you understand the monolithic structure. You just have to remember that in monolithic structure, entire operating system, or you can say the kernel, is implemented in the kernel space. All the functionality of the kernel is implemented in the kernel space, and this kernel is a core component of the operating system, and it is going to deliver basic services to all the element of the system. Next is the microkernel. What is microkernel? In microkernel structure, the design of the operating system is such that it is going to remove all the non-essential component from the kernel. It is going to remove all the non-essential component of the kernel. These non-essential component of the kernel are implemented as the system software. It is implemented as the user program. So the system is called as the microkernel. All the non-essential elements are removed from the kernel space, and it has been implemented as the system software. It has been implemented as a separate software. So you can say that because of this ease, microkernel is made independent, and it has been isolated. It helps to make the system more secure, more reliable. So if any of the system software component fails, then other components are untouched and everything works fine. So the main advantage is it is reliable, it is safe, it is trustworthy, it can be ported to other system, and each component work in an independent manner. And as the microkernel are smaller, they are successfully tested. And over here also the main disadvantage. What is the disadvantage? Main is the system performance, because everything is implemented as a separate small system software or the programs. So whatever request is there, it needs to be passed via the various component, and it makes the system complex. So that is about the microkernel. What happened in the microkernel structure? Only the core component stays with the kernel part, whereas all the other non-essential component is ported as a separate system software. It is ported as a separate programs. It has been designed in such a way that it has been made in a separate system software and separate programs. So that is about microkernel. So just remember that in monolithic kernel, monolithic structure, entire operating system works in a kernel space. And if any of the component fails, then it can crash your system. It can increase. Main advantage is your performance will get increased, but it is not much secure, as any of the component fail and your system can come down. And in this microkernel, everything is implemented in a separate or a small element like your programs, and it is going to pass, or it is going to perform all the computation in the microkernel approach. Okay, so core component stays with the kernel, whereas the other components are being um, made as a separate software. Your last is the modular structure. What is a modular structure? It is considered as the best approach. As you can see, that operating system is made up of various components. So over here, your kernel has only the set of core component, and all the services are added dynamically as a loadable modules to the kernel during the runtime or the boot time. As the operating system itself is very large, so it is not brought up at the one go in your system. Only the core component is there with the kernel, and depending upon the user requirement, depending upon the services, the modules are loaded dynamically to the kernel during the runtime, during the boot time. So this is the best approach for developing any of the operating system, that is a modular structure. Modules. Your operating system is made up of various modules. So over here, only the core component is with the kernel, whereas the other component, other component which is also essential, it is brought up based on the requirement of the program, based on the requirement of the user. It will automatically find out. User will not put the requirement. User will just start working on, and the system will find out which modules needs to be brought up in the system during the runtime, during the boot time. So that is about the modular structure. So I hope that you have understood about the structure of operating system and how every structure works. So thank you for watching the lecture. Kindly like, share and subscribe to my channel. Thank you.